This is the tutorial on parabolas as conic sections. When we create a parabola as a conic section, it comes from when we take our plane and we intersect the double cone where the plane is parallel to one of the edges of the cone. When that happens, the conic section that we get is that of a parabola. Now, if we say that the vertex of our parabola is at the origin of an x and y axis, then we can write the equation of every parabola that has the same vertex in standard form. And this standard form is written as x squared is equal to 4py or y squared is equal to 4px, depending on which direction your parabola will open. Now, some textbooks also use the standard form of y is equal to 1 over 4c times x squared, or x is equal to 1 over 4c times y squared. Now, if you imagine that p is equal to c, then you may notice that if I divide both sides of these equations by 4p, that these two become the exact same equation. Now, some textbooks still, they have a different standard form of their equation. They'll say that a parabola is y is equal to ax squared or x is equal to ay squared. But then it should note that a is just equal to 1 over 4c. Now here we have some examples of parabolic equations. Y is equal to 1/16 x squared, or x is equal to 4y squared. X squared is equal to 8y, or y squared is equal to negative 4x. What's important to notice in all these equations is we can tell that these will form a parabola because either the x or the y is squared. But in each equation, only one of the two variables, x and y, is squared. If x is squared, then y is not. If y is squared, then x is not. So that's an easy way to recognize the equation of a parabola. Now, if I create a parabolic conic section by intercepting a plane with a double cone, and I looked on that plane straight or perpendicular to that plane, then I would see my parabola and I could imagine a coordinate axis on it with the origin at the vertex of that parabola. Then if I were to pick up this parabola and this coordinate axis and draw it, it would look something like this. I could call this my y-axis and this my x-axis, and then my parabola would be drawn here in blue. Now, every parabola has both a focus and a directrix. A focus is a point, and it's always inside our parabola, and our directrix is a line, and it's always outside of our parabola. Now, every parabola has an axis of symmetry. This axis of symmetry will pass through both our vertex and our focus. This axis of symmetry is also perpendicular to our directrix. What makes the focus and the directrix important is that every point on this parabola is the same perpendicular distance from its directrix as it is from the focus. This distance, that I'll call A, is the same distance here. This distance, that I'm going to call B, is the same distance perpendicular from our directrix. This is also B. And this stands for every point on the parabola. Another thing that we need to know about parabolas is which direction they're going to open. If x is squared, then our parabola is going to open in either the positive y direction or the negative y direction. If y is the variable that's being squared, say we had y squared is equal to 4px, then our parabola is going to open in either the positive x direction or the negative x direction. Now, how do we determine whether it's going to be in the positive or negative direction? Well, we can look at our A, P, or C term, again, depending on which standard form your textbook uses. If your a, p, or c term is positive, greater than 0, then your parabola will open in the positive direction, whether that be y or x. If your a, p, or c term is negative, less than 0, then your parabola will open in the negative direction, again, whether that be y or x. So now let's talk about what these p and these c and these a terms mean. Well, if you have y is equal to ax squared, then you know that a is equal to 1 over 4c. And we discussed earlier that p is equal to c. Well, p and c are important because p, or c, is the distance from our focus to our vertex. Now remember, both our vertex and our focus is on the axis of symmetry. So if we go from our vertex to our focus along the axis of symmetry, we'll find that this is p distance away. Or if you're using the other standard form, it's c distance away. Now remember, every point on this parabola, including the vertex, is the same distance from the focus as it is perpendicular from the directrix. So if the distance between our vertex and our focus is p, or c, then the distance between our vertex and our directrix is also p, or c, depending on which standard form of the equation you use. This distance between our vertex and our focus, or our vertex and our directrix, controls the amount of curvature that our parabola has. So now let's use what we found out about the focus and the directrix to find the focus and the directrix of this parabolic equation. And then we'll graph this conic section. Now we have y is equal to 1/8 x squared. So I'm going to write this in standard form, and depending on which standard form you use, if you use y is equal to 1 over 4c times x squared, then this is already in standard form. If you use the other standard equation, x squared is equal to 4py, then you need to multiply both sides of this equation by 8 to get it into standard form. Now, since our first example here is already in standard form, y is equal to 1/8 x squared, that would mean that 1 over 4c is equal to 1/8. And that means c is equal to 2. If you use the other standard form, x squared is equal to 4py, and I multiplied our original equation by 8 on both sides, we would get x squared is equal to 8y. And that would mean 4p is equal to 8. And if we did that math, we'd find out that p is equal to 2. So we know the distance between our vertex and our focus and our vertex and our directrix. Now to find the actual location of both of these, we're going to need to draw our conic section. Looking at our original equation, it is x that is squared, so that means that this is going to open in either the positive y direction or the negative y direction. Going back and looking at our c term or our p term, whichever one you use, these are both positive. So that means we're going to open in the positive y direction. So our parabola will be shaped like this. Now this is the standard form of a parabola with its vertex at the origin. So we know our vertex is at the origin, or the point 0, 0. Now since our parabola opens upward, that means the y-axis is going to be our axis of symmetry. And our focus is the distance of 2 away from our vertex along the axis of symmetry. And we also know that the focus is always inside the parabola. So that means it's going to be above our vertex. So our focus is going to be at the point 0, 2. Our directrix is a line that's perpendicular to our axis of symmetry, and it's also 2 distance away from our vertex. So if our focus is up, then our directrix is down. And our directrix is the line y is equal to -2. And I can draw that in. So now that I've found my focus and my directrix, all I have left to do is sketch this conic. We would need a couple points. If I plug in +4 for x, I'll have y is equal to 1/8 times 4 squared. 4 squared is 16, and multiply that by 1/8, and we'll get y is equal to 2. So we have the point 4, 2. And again, if we're symmetrical across our axis of symmetry, then we also have the point -4, 2. And if we connect these 3 points with a smooth curve, our parabola should look something like that. Now, so far, all of the parabolas that we've dealt with have had their vertex at the origin, or at the point 0, 0. But what if our parabola didn't have its vertex at the origin? What if it had it at some other point? And I'm going to call that point HK. So if we had a parabola that had its vertex at the point 3, 4, that means h would be equal to 3 and k would be equal to 4. Now when that happens, when we translate a parabola from its vertex being at the origin to some other point, all we do is take our standard equation. Here I typically use the x squared is equal to 4py, or y squared is equal to 4px. You may also be used to y is equal to a times x squared, or y is equal to 1 over 4c times x squared. It doesn't matter. When your parabola is translated to the point hk, all you do is take every occurrence of y and replace it with y minus k. Everywhere you have an x, you replace it with x minus h. Remember, h and k are the coordinates of your vertex. So again, whenever you have a parabola that has its vertex at some other point other than the origin, take your standard equation and replace y with y minus k and x with x minus h. So now let's try one of these problems. Here we're told to graph the parabola x squared minus 6x plus 9 is equal to 12y minus 48. Notice that our x is squared and our y is to the first power. So you can think of that as being in the form of x squared is equal to 4 times p times y. Now if x is squared, that means that this parabola is going to be opening in either the positive y direction or the negative y direction, again because our x is what's being squared. Now looking at this equation here, this is not in standard form, but x squared minus 6x plus 9, I can factor this. It's a perfect square, so I can write this as x minus 3 squared. Now on the right hand side, this 12y minus 48, I can factor out a 12, and I'll end up with y minus 4. Now this equation is in standard form. You can think of this as x minus h squared is equal to 4p times y minus k. That means our h value is 3 and our k value is 4. And that tells us right away that our vertex, that's the point 3, 4. Now that also means that this 12 here is our 4p, which means p is equal to 3. So that tells us that our focus and our directrix is 3 units away from our vertex. So let's plot our vertex. 3, 4 is right about here. Now, none of these terms in this equation are negative, so our parabola is going to open in the positive y direction. And that means our focus, which is always on the inside of our parabola, will be above my vertex. And I know that it's 3 units away. So if I go to my vertex, which is at the point 3, 4, and I move upward, because that's the direction that my parabola is opening, 3 units, or a p of 3, I'll come to this point right here. This is my focus. My focus is at the point 3, 7, because it's 3 units, or p units, above my vertex. I can also go down 3 units and find my directrix, which would look something like that. Our directrix, that's the line y is equal to 1. And again, it's 3 units below our vertex, or p units below our vertex. So I have almost everything I need. I should probably find one more point to plot my parabola. I'm going to pick an x value that's simple to solve for and plug it into this equation again and solve for y. So I'm going to say x is equal to negative 3. If I plug that in, I'll have negative 3 minus 3 squared is equal to 12 times y minus 4. Negative 3 minus 3 is a negative 6. Negative 6 squared is 36 is equal to 12 times y minus 4. Divide both sides by 12. You'll get 3 is equal to y minus 4. Add 4 to both sides, and you'll get y is equal to 7. So now I have the point negative 3, 7. That point is right about here. Now, since my parabola is symmetrical across the vertex and the focus, that would mean I would have another point right here at 9, 7. And I can connect the dots, and my parabola would look something like that. So the only thing that changed was my equation. Now I'm using this x minus h and a y minus k equation. But the way I used my value of p didn't change. I just moved everything from the origin up k and over h. So now let's try a different problem. Here we're told to write the equation of a parabola with its focus at 1, negative 3 and its vertex at 1, 0. Always with conic sections, it's always easiest to draw a picture. So we'll need an axis. I have a vertex at the point 1, 0, which is right here. I have a focus at the point 1, negative 3, which is down here. If my focus is below my vertex, that means that this parabola is going to open downward. Since it's opening downward, I'm going to use the equation x squared is equal to 4py. But since it's opening downward, I'm going to say negative x squared is equal to 4py. And then notice that our vertex here is not at the origin. So instead, I'm going to use the formula negative x minus h squared is equal to 4p times y minus k. Now I know what h and k are. H is 1 and k is 0 because h and k are just the coordinates of our vertex. I can also find my value of p. Remember, the value of p tells us the distance between our vertex and our focus. Well, this distance here is 3. So that means p is equal to 3. So if I plug all these values in, I'll have negative x minus 1 squared is equal to 4 times 3 times y minus 0. So my equation then is negative x minus 1 squared is equal to 12y. And that would be our equation of a parabola that has its vertex at 1, 0 and its focus at 1, negative 3. So it's important to notice that even though we're using a slightly different equation, one with this x minus h and y minus k, P still tells us the distance between our focus and our vertex, or our vertex and our directrix. So even though we've moved our parabola over 1, or to the right 1, what P does is affect how wide or how open our parabola gets. And even though we've moved it, our value of P doesn't change. So that's how you deal with parabolas that do not have their vertex at the origin. And that completes our tutorial on parabolas.